We have networks. This is our topic today. A network is defined by a group of nodes and edges called graph. Okay, and a graph is what we will look at today. Is a set of nodes and edges. Wait a second. A graph is a set of nodes and edges. Please close the door. Wait a second. I find my notes here. Here. It's a set of nodes and edges, so a union of the nodes here, and the unions between the nodes. Edges can be directed if they have an arrow, or undirected. We will look at directed nodes, edges here in this lecture. So we are going to learn today how to quantify and compare networks. Okay? So we will do that with 3 KPIs. The first one is called average path length. The second one is called clustering coefficient. The third one is called degree distribution. Okay, 3 KPIs, and then we will look at the Laplacian of the matrix. Oh, Laplacian matrix of the graph, sorry. So this will be our lecture today. Okay? So the first one is called average path length, in short APL. Okay? This is the average distance between the nodes. Formula you need to know, and no, there will be no list of formula allowed in the exam, so you have to know it. Okay, is 1 divided by n times n minus 1, the sum to n between all distances of all nodes to each other. Okay. So the best thing is to do an example. I painted an example above, so we will do the example above. The average path length of that example, of that graph, is 1 divided by n is the number of nodes. Okay. We have 6 nodes in that network above. Okay, 1, 2, 3, 5, 4, 6. N is 6. 6 minus 1 times. And now, best is if you look at the image, okay? For node 1, I need 1 step to go from node 1 to node 2, right? Look at there, not at me, look at there. I need 1 step to go from 1 to 2. Yes or no? Yeah? I need you to give me some feedback, otherwise will not work. Okay, so this is the distance between 1 and 2 is 1 step. Plus the distance between 1 and 3, how many steps? 1 step. Okay? So the distance between 1 and 4 is 2 steps. The distance between 1 and 5 is 1, 2, 3 steps. The distance between 1 and 6, 1, 2, 3 steps. All right? So this is the distance between 1 and everybody else. Is okay for you? Then note 2. The distance between 2 and 1. Look at the graph. Can you go from 2 to 1? No, it's only one direction, okay? So there is no distance between 2 and 1, so 0. Distance between 2 and 3 is 1. Distance between 2 and 4 is 2. 1, 2. Distance between 2 and 5 is 1, 2, 3. 1, 2, 3, okay? Distance between 2 and 6 is also 3. So is that clear, the way to do it? Now, distance between 3 and 1, 0. Distance between 3 and 2, 0. Distance between 3 and 4, 1. Distance between 3 and 5, 2. Distance between 3 and 6, 2. Okay? So please do the remaining. I will be copying, okay? I will do the same for 4. Now you can write. If you understood, you can write. Go ahead. Distance between 4 and 1, 0. Distance between 5 and 1, 4 and 2, 0. 4 and 3, 0. 4 and 5, 1. 4 and 6, 1. With 5, 5 and 1, 0. 5 and 2, 0. 5 and 3, 0. 5 and 4, 0. 5 and 6, 1. And 6 has no outgoing, so for 6 is everything 0. So you add it up. You can do it in your mind. You can do it super fast with a non-programmable computer you will have, or your non-programmable calculator that will be allowed in the exam. You compute these numbers, and then you put a number here. Okay? Is that cool? Understood the concept? Not super difficult, but you need to know it. You need to have seen it once at least. So what's the key here? The best average path length is the shortest. And this is important that you understand. The shorter the average path length, the faster we get information on or material or whatever money from A to B. Okay? So we want a short average path length if we have a logistics network, if we have an information network, if we have a production network or supplier network, whatever. We want an average path length that is very, very low. The shortest, the better. So when you compare two or more networks, the one with shortest average path length. Can you open the door? Maybe the internet is bad because of the door closing. Sorry. Would be usually faster or more effective. Okay? So that's important. If I ask you in the exam, hey, here are two networks, compare them. You need to calculate the average path length for both. Then say, okay, this one is better because average path length is shorter. Okay? Is that cool? Fragen, questions? Second KPI, clustering coefficient, describes how good groups are created in the network. Okay. So the clustering coefficient formula is like this: 1 divided by n. And don't worry, I will explain right now what this letter means. ei to n, 2 times L sub e divided by k sub e minus 1. So what is the meaning of these letters? First I write the meaning and then we see an example. You will see, don't be scared. After we see the example, everything will be super clear, okay? So n is the number of nodes, just as we had. L sub e is the number of relationships between the neighbors of node E. Okay? This means how many friends of E, of I guess, are friends to each other. In other words, if you are a friend with him and you are a friend with him, L sub E will be 1 if you and you are friends. Okay? And will be 0 if you're not connected in friendship. So the number of my friends that are friends between each other. Okay? Die Anzahl von meinen Freunden, die untereinander befreundet sind. Okay? So this looks complicated. K sub I is the number of nodes. Okay, that's plain. So if we have the same network as before, 1, 2, 3, then 3 to 4, 4, 5, 6. That's the same network as before. The clustering coefficient is 1 divided by 6. And now look at the picture again. Okay. We do it for node 1. Node 1 has, look at the picture. Hey. Node 1 has neighbors 3 and 4 and 2. Okay? Are they connected? Yes. So L sub 1 for node 1 is 1 because my friends, I am node 1, my friends have 1 connection between each other. Okay? Does this make sense? So this is 2 times 1 divided by 2 neighbors, 2 minus 1. This 1 is because my 2 friends have 1 connection. Okay? Later you have the video so you can look at it as many times as you want. For node 2. Node 2 has only 1 connection. So here we can stop right on our foots and say, okay, 0. Node 3 has only 1 connection, so 0. Node 4. How many neighbors do we have? 5 and 6, right? Are they connected? Yes. So 2 times 1 divided by 2 neighbors, 2 minus 1. For node 5 is 0, for node 6 is also 0. Okay? Make sense? So now you can write, please. If you understood the concept. This can be done quite fast. Is 2/3 to 6, then 1/3. Okay? So here what we are measuring, are you done copying? Hey, I need you to give me feedback. Yes, no. Yeah. The higher the clustering coefficient, the better the communication between the elements. Of the network. Okay? Why? Because the better they are communicating in little groups. Imagine you will have a department of people and you want them to exchange information so that everybody knows the same things. So you want a high clustering coefficient in your group, right? So the higher the clustering coefficient of a network, the better the information will be spread. You have better groups. Here, if you look at this network, where is the bottleneck? Here, right? If this node fails, between 3 and 4, you don't have a network anymore. Okay? And it's exactly the node number 3, the one who is spoiling the whole dynamic. If we add some nodes here, imagine here, or even here, then we have a totally different network. We don't have a bottleneck anymore here because we can go other ways. Okay? Good. So the third concept here is the Laplacian matrix. Okay. It contains all relevant information of the network. Okay, is defined as Laplacian equal degree matrix minus adjacency matrix. L D minus A. Okay? Laplacian matrix degree matrix and adjacency matrix. Okay, so it's quite easy. Again, let's get the same example. 1, 2, 3, 4, 5, and 6. Okay, so the degree matrix is defined as the number of nodes in the diagonal and 0 out of the diagonal, and the adjacency matrix is defined as one if connection between I and j and 0 otherwise. So you can say, oh my God, again, math. No, it's super easy. Okay, just look at the example. It's very, very simple. The Laplacian matrix is the degree matrix. In that I have 6 nodes, so how many neighbors does node 1 have? 2 neighbors, right? And the rest are zeros. So zeros out of the diagonal, how many neighbors does node 2 have? 1. The rest are zeros. 0, 0, 1, 0, 0, 0. For node 4 is 0, 0, 0, 2, 0, 0. Node 5, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 1. Okay? So this is for node 1, 2, 3, 4, 5, and 6. Minus the adjacency matrix. And the adjacency matrix is just connecting the nodes 1, 2, 3, 4, 5, and 6. So node 1 to node 1, no connection. Node 1 to node 2, connection? Yes, so I paint a 1. Node 1 to node 3, connection? Yes. Node 1 to node 4? No. Node 1 to node 5? No. No. Node 2 to node 1? No. No. 1, 0, 0, 0. 3, 0, 0, 0. 1, 0, 0. 0, 0, 0. 0, 1, 1. 0, 0, 0, 0. 0, 1 for node 5 and 0, 0, 0, 0, 0, 0 for node 6. And now what do? We subtract. I mean, this is easier than taking a shit. 2 minus 0 is 0, right? Again, 0 minus 1 is minus 1, right? Minus 1, 0, 0, 0. 0 minus 1, minus 1, no, sorry. 0, 1, minus 1, 0, 0, 0, then 0, 0, 1, minus 1, 0, 0, 0, 0, 0, 2, minus 1 for node 4, and this is 1, 2, 3, 4, 5, and 6. For node 5, 0, 0, 0, 0, minus 1, no, sorry, plus 1, minus 1. For node 6, 0, 0, 0, 0, 0, 1. This is a Laplacian matrix. This question was asked last semester. Calculate average path length, clustering coefficient, and degree and Laplacian matrix of a network just like this. Okay? Yeah.
Why does node 6 have a neighbor?
6 has no neighbor because there's nobody out of 6.
Yeah, but on the degree matrix we have a 1 at the 6. 6, 6, 1.
Yeah, you're right. This is a 0. Thank you. Thank you. Okay, so that's the average path length, clustering coefficient, and degree distribution, and Laplacian matrix. The last thing that we see is the degree distribution. The degree distribution is just a statistical distribution of the degrees. So if we have here again the same network, 1, 2, 3, 4, 5, and 6. We ask how many nodes have how many. So this is just a frequency, and like in any distribution, the sum of the distribution of the frequencies are 1. How many nodes have one neighbor? One neighbor, number 2, number 3, number 5, number 6, right? No, number 6 has 0 neighbors. 0 neighbors is number 6. How many nodes have one neighbor? 3, right? So 3 divided by 6, the total is 6. How many nodes have 2 neighbors? 1 and 4, 2, and we're done. Okay? I like to paint the nodes so that I don't forget any. This is the degree distribution. Of course, if we have a network of 6 nodes, we can do it with a piece of paper. We have 6,000 or 6 million nodes in a network changing constantly, like IoT or some logistics network. It's impossible to do it by hand. You need a computer. And that's why we need people that know not only informatics, but also economics. So Wirtschaftsinformatik. Good. So a key factor here is no, I'll explain something different. So the topology of the network. Okay, so the probability that a node with k neighbors attaches, I mean, a good way to visualize this is like a Facebook network, okay, or a friendship network, or Twitter network, or something, or Insta, whatever. New node in a random network is given by a Poisson distribution. Those of you who visited statistic in second semester with me know that with parameter lambda. So the probability that x equals k in a random network, it's lambda hoch k, e hoch minus lambda divided by k factorial. Okay? This is for a random network. And the probability that a node is connected to another with k networks. Imagine you enter in a group of people and people are friends to each other. What is the probability that you meet somebody and are friends with this person if this person has k friends? Okay? This is what we're looking at. In a real network, is given by probability for real network k to the potent of gamma, and gamma is the exponent degree. Okay. Here, if you want to read a very good book about networks, you can go ahead and read Network Science by this author, Barabasi, in 2016. The best book about network science there is, okay? I totally recommend it for everybody because everything in management are networks, but it's outside of the scope of this lecture. So the thing is that when we plot the information, when we plot the degree distribution of one random and one real network, we say this is the logarithmus of the number of nodes, this is the logarithmus of the probability, okay? We have following behavior. The random network will behave like this, and the real network will behave like this. Remember, this is a logarithmic So fact of the matter is that we have three phases here. Phase 1, in which the random network, or in which the real network is higher than the random network. Phase 2, in which the random network is higher than the real. In phase 3, the real is higher again. Okay? Important for you as managers of the future. Here, real networks have a part of their nature in which they have nodes with a lot of friends. We call them influencers, right? People that Taylor Swift, she takes a piss and 100 million people know. Okay? So this is a hub. It's somebody that has a lot of neighbors. Okay? It's a hub. Real networks have hubs. Like your brain is a real network, the network of Facebook, the network of whatever. Okay? Important is that you make sure you take care of your networks, because if you don't identify the hubs in your department, in your process, in your production, you will not be able to protect those hubs. Imagine you are dealing with like a server, like you are a manager of many servers of an internet provider. If some attacker attacks one peripheral node, something happening outside, some computer, nothing happens. If they attack a hub, you're fucked. You get it? So you need to identify the hubs. You need to know what your network is about. This is probably one of the most important lectures you had, because everything you will see in management will be networks. Networks of people, networks of money exchanging, networks of logistics, networks of production. I don't care. Networks of products interacting with people, interacting with machines. Everything is networks. So you need to learn to identify, quantify, and measure your network, because it will be different and it will be dynamic. It will be changing all the fucking time. Okay? In order to make good decisions, because if you're a manager of this network and you don't identify that the friendship between 3 and 4 is crucial, and these guys break up their relationship, you will be having 2 departments like logistics and production if 3 and 4 don't talk to each other anymore. And then you have a problem as a manager. Okay? Same thing happens in friendship relationships. You can map your friendships like this. You can identify bottlenecks, you can identify interests, you can identify, you have, in half an hour now, you have magic powers. You can look at reality with different glasses. Okay? This is super important. We will dive into this tomorrow in our next lecture, but this is like the very basic steps, and I totally recommend, I mean, of course, your decision, but this book for your further development. Okay? Good. Any questions?